Welcome to week 1 of remote teaching in Organic Chemistry 1 lab. Today we're going to go through acetanilide, the production of. It is an aminization reaction, that is, we're creating a new amide bond between what was a carboxyl carbon and a nitrogen. In order to do this, we're going to use a carboxylic acid and an amine. Amines and carboxylic acids are what you use to create amides. Amides are made from carboxylic acids and amines. Just like last week we saw carboxylic acids and alcohols make esters. That's a hint, by the way, you still have a final. Okay, so today we're using aniline or aminobenzene and the acetic anhydride form of acetic acid. So the source of the electrons, here again we're going to go through the reaction mechanism, which means we're going to push electrons from here or there. The source of the electrons are the unshared pair on the nitrogen, as it's more than willing to donate them. And the target then is our carboxyl carbon, just like when we were doing the esterification. The carbon there is very slightly positive, and it's nice and open. So we draw in our unshared pair, and then we show the movement of the donation to the carbon. Now that carbon already has 4 bonds, its octet is full, so something has to give. And the most likely thing is one of the bonds, that is the pi bond to the oxygen, as pi bonds are weaker than sigma bonds. That gives us our first intermediate. Here again, that's a Zwitter-ion intermediate, as the nitrogen, now with 4 bonds, has a positive 1 formal charge, and the oxygen, gaining those unshared electrons, has a -1. Okay, but that is an intermediate, it's not isolatable, so the process continues. We're going to bring down the electrons, reforming the pi bond, okay, and here again, then something has to give. If it's the bond between the nitrogen, we're back where we started, okay? But eventually, it's the bond between the carbon and the other oxygen. Stepping in front of the board is probably not the best video technique, but there you have it. Okay. Here again, that bond between the carbon and the oxygen is okay to let go because the acetate ion then is very stable. It's resonance stabilized anion, so it can go floating off. Okay. Now, probably the best thing that's around is some water as a base as opposed to the acetate. We're going to pull one of those hydrogen off so that the amine nitrogen becomes the amide without being charged. So primary amines go through aminization. Secondary amines, also tertiary amine would not do this. It gets to this point and you can't deprotonate it, there's no hydrogen left. So everything reverts back through the equilibrium as you try to clean it up. Okay? The reaction mechanism. Procedural notes, okay, that you would have to make note of if you were actually here. Aniline is a breathing irritant, but it is a liquid, so it's not too bad. Okay? The acetic anhydride is a topical irritant. Here again, gloves, or if you don't and you start to scratch, you know you've got some on you. Okay. The 2.5 mils of acetic anhydride we're going to add dropwise with swirling. Okay. And we're going to preheat our gravity funnel and filter paper so that it's nice and hot, so that if we do end up putting charcoal in, and I'm going to do one where I do, we can get it filtered. Because the acetanilide is soluble in water close to boiling, but not soluble otherwise in water otherwise. Okay. Now, since we're using water as our solvent, the idea of the charcoal flashing or suddenly combusting is not too bad, but you would always want to not be staring directly into your flask as you added the charcoal. We're not going to pull out any of it. I'm actually going to do two reactions side by side, one that has charcoal and one that doesn't, and we'll compare the crystals at the end of it. We're going to dry it, and eventually I'll get you a mass, and you're going to work it up as if that was what you did.